Hi, hello, and welcome. We are broadcasting live from GlobalAIPreneurs, the premier global gateway and unified operating system for trusted AI enterprises. Right now, we are witnessing an unprecedented paradigm shift. That AI landscape is expanding exponentially, stretching across 8 plus categories and over 120 distinct technologies. Yet, this explosion has brought an unit ended bottleneck. Enterprises buyers are facing severe decision paralysis, investors are swimming in unvetted noise, and brilliant founders remain isolated from the cross border institutional bridges they need to scale. The results are clear: capital inefficiency and deployment friction. Promoted by the Global Council for the International Trade and the Global Council for the Artificial Intelligence and Robotics. The global AIpreneurs was built to change the narrative. We are moving decisively past passive directories via a multi-layer engagement engine spanning technical operational reviews and community rankings, connecting enterprises' demand directly with trusted AI supply. Operating across our primary global hubs in India, Singapore, UAE, Saudi Arabia, the USA, the UK, Switzerland, the EU, South Africa, Kenya, Ghana, Nigeria, we are bridging the gap between raw potential and institutional deployment. Today, as part of our interview series, we are chatting a future of this ecosystem. Joining us as a leader who embodies exactly what it means to build with high intent, high density, and absolute impact. Please welcome our distinguished speaker today, Ashish Dhamin. Ashish Dhiman is the founder and CEO of Frozo Software and the creator of EdgeGate, an AI verification platform designed to make Edge AI deployments reliable, measurable, and production ready. With more than 15 years of experience in embedded systems, Android platform development, AI acceleration, and Qualcomm Snapdragon technologies, he has built deep expertise in validating AI workloads on resource constrained edge devices. Through EdgeGate, Ashish is helping organizations verify AI model behavior after optimization, validate hardware acceleration, ensure functional safety, and generate crypto- cryptographically signed evidence for enterprises, deployment, and regulatory compliances. His work spans edge AI infrastructure, AI assurance, on device LLMs, model verifications, machine learnings, trustworthy AI deployment, and production grade AI systems, helping bridge the gap between AI innovation and enterprise stresses. Ashish, thank you for joining us today and for helping to shape the future of the global AI readiness. Thank you for joining us today.
Yeah, thanks, Sushma, for the introduction. I'll just introduce small about me. So, my name is Ashish Dhiman. So, I have like around 15 to 16 years of experience working on the embedded systems. I was part of Qualcomm team, then I was part of Samsung Research and the Texas Instruments. So, I have worked on various Snapdragon platforms, firmware, and getting the AI workload to actually run on a very memory-less devices, hardwares. So what we are trying to solve is one simplest way to describe EdgeGate is before you ship a model to a device, EdgeGate runs it on a real silicon it lives on. So all the checks that should be happening on the device does happen because nowadays companies don't actually test on a real silicon, they test it on cloud servers. So that's what the gap EdgeGate is trying to resolve. So the reason that product that's a product and not a script because nobody has done it. And test team models, all the test team actually runs the model in the cloud and ship binaries to the devices. And that gap is really real and behavior can really change in the AI when you are really running on the device.
So
Yeah,
as a
so
small
this is our platform, EdgeGate. This is our website. So what we do here is I have so whenever a test team runs any model changes, they actually don't run on a actual hardware. So if they run on a cloud GPU, their accuracy might match 95%. But whenever it hits any production vendors, that accuracy can drop by 71%. So that's a real behavior change which you see in the AI models which we are going to deploy. So, so the key takeaway from this is hardware is unpredictable, thermal throttling is there, firmware updates is there, power states always change, and test team really burn their work hours trying to figuring it out. It could take around 2 to 3 days to validate this problem, and Edgegate solves it in 5 minutes. So that's the real gap we are trying to figure it out. And regression ships silently a weight update that may look fine in the training pipeline, but when it hits the hardware, it might um, get the complaints from the customer that it's not behaving as it was doing previously. So, so that's the thing. And the real value here is if you see AI ships to devices with no proof that it works. So we have already lost like billions, like Tesla, BMW, Hyundai have recalled their vehicles, which could have costed them $1 billion because the software they have shipped, they have not tested it properly. So that's the $1 billion industry right now. If we can save that money, so that's the real edge case here. And we have made it very easy for customers to use. So you can integrate it with your CI pipeline, add your gates, configure it once, and every time you push a new GitHub PR, it will be automatically tested on GitHub uh, on the edge gate, and you can clearly see all the results on the edge gate. So once you see, I will go over the dashboard of the EdgeGate. So these are the tests we have run on real devices. So if we can open this, we have run these models, all the newest models, AI models, which we have run here. And it is showing all the gates which you have configured. Have they passed it or not? If they don't pass, your GitHub PR get blocked. So you can just see what could be the cause the issue and update the PR, and the real test runs again automatically. So you don't have to do the testing again and again. Just push the changes. So if you can see here, we are comparing multi-model, multi-device metrics are there. We can deploy the same model on different devices and check their values, how it is going. Then we have the metric delta. Uh, like the compile time, all the important metrics which a development team will need to figure it out why it is behaving the way it should be, right? So these are all the details. Then we have the behavioral gates where you can test your LLM models for the behavior. Like if you can see, if you are making a model for a car, right? So car has very safety regulation like seat belt should be ready. So once you say something to LLM, it doesn't behave, it should be your safety could be a really concern. So you would have tested your model here. Is the behavior working properly or not using the behavior gate? And then you can update your automobiles with those software. So we give evidence bundle and everything is signed. You can download the report. You can see here, if I open here, so we have the ISO 26262 report, which is evidence bundle that nothing is tampered by. This is all real values which are coming from the hardware and it is signed. So it's like a referee. It can also be used by multiple vendors to, I can say to be a neutral referee on how on different silicons the models are behaving, and they can compare the values between different vendors like Qualcomm and Nvidia. So currently we are supporting two platforms. If you can see, we have multiple devices. We have Jetson Orion Nano from Nvidia, and we are supporting a lot of other devices like Samsung Galaxy S25, Google Pixels are there. We have reference platforms also is there, right? And then we have PC compute platforms are there where you can test. We have a wide variety of devices where your model can be tested easily and comfortably. And apart from that, we have made it more easy than this. You can just put it our MCP server to the cloud, and you don't need to open this dashboard and everything. You don't need to configure anything. You just put a simple prompt there, and all the setup will be done automatically, and your pipeline is ready to be tested. So that is like a 10-second job for you now. Um, So this is the MCP. You can get it free from the open source market. But to use the Edgegate, uh, there are some pricing we have kept. So we always care about the developers. So there is a playground where you don't have to pay anything, no credit cards. You can run 2 devices per run. So one repeat, no medium of n, and 7 day retention period we have. Only one user can do it. So we have already in discussion with the few companies. We can't take the names of them because of the NDA thing. So it's a famous European automotive company. They are in talk with us. Let's see how the discussion goes. But they really liked our demo and the problem we are trying to solve. In a nutshell, this was the Edgegate, Sushma.
Yeah, yeah. So thank you for sharing your work and about your organization and the company. So shall we start our interview?
Yeah, sure.
Yeah. So my first question is, as AI rapidly moves from the cloud to edge devices, organizations face new challenges around reliability, performance, and trust. Based on your experience building EdgeGate, what are the biggest challenges enterprises encounter when deploying AI at the edge, and how can they ensure their AI models remain reliable and production ready?
Yeah, so from my experience, why we build the edge gate, because we have identified 3 reasons behind it, which are very solid. The first one is the silent NPU fallback. So you optimize a model, deployed it and runs, but nothing error is coming, everything is executing. But the problem is it is executing on the CPU or a GPU. Instead, it could have run on a NPU. So you design the entire product around it, but you never knew that what hardware it is using. So your latency gets multiplied off, your power budget is gone, and no alert fires, right? And because the test suits only ever asserted that output exists, right? So that's the one challenge we are trying to solve. This is the biggest challenge. We have actually solved it in Edgegate. And the second is the quantization of the AI models. So most of the people or team can think quantization as a compression step, but it is not. It is actually a transformation that changes the behavior of the LLM model. Um, so, it has been shown in recent published papers recently that the quantized models pick up the measurable behavioral bias, right? While perplexity stays essentially flat. So every dashboard say model is fine, but the answers might be completely different when you ask them a question. So that's also we are trying to catch in Edgegate, that how the quantization is changing the behavior of that model. So third is a very important one, is the thermal and the memory. Whatever benchmark currently vendors run on models are cold number benchmarks. They have never run it on actual device, field device, which is actually hot, throttled with lot of apps running and low in memory. And that's what we also are solving with edge gates, right? So that's 3 main reasons, I would say, biggest challenges which running AI on the edge devices, uh, enterprises will face, and they have to prove it as the EU Act is coming in play in 2028, I think. They have doing the mandate that all these numbers you have to prove actually it is happening or not on the device. So that's where the edge gate comes into picture, solving these biggest challenges. Yeah.
Thank you for sharing those valuable insights. It's fascinating to see how Edge AI is transforming enterprise system by bridging intelligence closer to the point action. So let's move to one to my next question. So your work focuses on AI verification, hardware validation, AI assurance, and deployment pipelines. What practical framework would you recommend for organizations looking to build trustworthy AI systems that can scale securely while meeting enterprises and regulatory requirements?
Right. So first is a very obvious one. You have to test on a silicon, not the simulators. So whatever emulated accelerator behavior they are seeing on the program running on a simulator, that is not correct. You are when you are running a verification on a target hardware, that's the actual verification you are doing of the model, what you expect it to do. First, most of the companies I have seen running AIs, they only calculate the metrics like the NPU, GPU metrics, latency metrics, the hard numbers. But people forget about the behavior regressions, right? Whatever answers models are giving, are those expected or not? Nobody is testing that. Did the answer change? If you have done some changes in the model, are the answers correct? What are being said given by the behavioral model? So that's the second point. The third point is we need to make the evidence. We need to have the evidence. So suppose you are having a automotive device running AI. So when the insurance company says some accident happens, you will have to prove to insurance companies that it was not a mistake of the car automotive driver, it was a mistake of the driver. Insurance company won't give you will say that it won't go by your word, so they will need evidence. So we provide those evidence actually. So that's the major thing. Next thing is coming in the regulatory requirements. We have to make the evidence cryptographic and per device class. So that's the another thing. And now currently verification which is living outside the pipeline has become optional. And optional means we have skipped the verification, right? So on the regulatory side, the audit question is never is did it pass? You have to prove that it passed on what hardware, on what data, against what reference. So that's why the output should be signed. So you are producing a claim, you are producing an artifact. So those are the four things which I say. Fourth one was putting in everything is as a part of verification in one pipeline, not make it optional. Yeah. So these were the 4 points which I would say the practical framework should any AI companies should take in account when considering regulatory requirements.
Yeah, that's a very interesting perspective. So it highlights the importance of what the 4 points it's need to be focused on the AI startups or enterprises. So moving to our next question, where many AI startups build impressive models but struggle when deploying them on real hardware to at scale. From your experience, what are the most common technical mistakes founders make when commercializing edge AI solutions, and how can they overcome these challenges?
Right. So I can think of three reasons. So one is whenever a company makes some models, AGI models, they will benchmark on a dev device and code those numbers to enterprise buyers. But a dev kit is thermally very unconcentrated and has a lot of memory difference than the target hardware which you are going to run. And customer device might be totally different. So for them, the demo might work, but deployment doesn't, right? So and that generally the founder that they don't understand this problem. Second problem, which I have talked earlier also, but I will say it's the most expensive misunderstanding in this space, the quantization, treating quantization as a compression step. So founder optimize for size and latency, but they don't optimize for behavior. So how the behavior has moved, the matrix is doesn't build to see it, right? So third point is building for one chip. So you get a design win, you optimize hard for a particular vendor or SoC, and then the customer say, I have a different hardware, it needs to run on two different hardwares, then how you will be optimizing? So that also need to be considered when you are commercializing edge AI. It should work across multiple vendors at least. At least you should know your vendor details, have a abstraction layer per vendor that might help you, building for more chips, not just for one chip. So the pattern is same, like founder should optimize what they can measure and tooling to measure the thing that actually breaks them didn't exist. That's not a discipline failure actually, it's a missing layer. So yeah, these are the 3 points I would say technical mistakes uh, most of the founders in Edge AI people are struggling to.
Yeah. Thank you so much for your insights. I'm sure many founders and enterprises in our audience will benefit from this experience. So let's move to our next question. Where you have worked extensively, worked with embedded systems, AI acceleration, Snapdragon platforms, and edge AI infrastructure. Looking ahead over the next 3 to 5 years, how do you see on device AI, edge AI, and AI agents transforming industries such as automotive, manufacturing, healthcare, and smart infrastructure?
Right. Okay. So let me take a very good example, the automotive cockpit, which we have already discussed on it. So the automotive cockpit is like a safety agent running many SKUs across a long product life cycle, and it is getting heavily regulated. So every hard property converges there at once. If you can verify AI in a cockpit, the other verticals are easier versions of the same problem. Then we can generalize manufacturing wants determinism, the same input producing the same action, shift after shift. Healthcare want audit reports, being able to reconstruct why a device did what it did. It's very important in a healthcare department. Smart infrastructure want unattended reliability because nobody is driving out to reboot a sensor, right? Those sound like three different requirements, but there is only one requirement, the evidence. So reproductionable proof of how model behaves on a specific hardware under specific conditions. The shift I would predict over the 3 to 5 years is that fleets get heterogeneously faster than tooling does. Same product, 20 different variants, each with different quantization behavior. Verification stop being a checkbox and become matrix problem. And once agents are running on device, behavior regression isn't worse answer anymore. It's a wrong action taken automatically with no human in the loop catch it. It can have dangerous effects also. So my blunt prediction is shipping an edge model without device level verification, behavior evidence will look the way shipping firmware without version control look the way. So these are the my predictions for maybe for next 3 to 5 years as edge AI is going to be popular very much in next to 3 to 5 years. Yeah.
Yeah. It's exciting to imagine like how edge AI, one device intelligence, and autonomous edges will reshape industries over the coming years. So I'd like to move to our final question, the last one.
Mhm.
So GlobalAIPreneurs aim to become one of the world's leading ecosystem connecting AI founders, enterprises, investors, governments, and technology leaders. Based on your experience building trusted AI infrastructure, how can initiatives like GlobalAIPreneurs accelerate enterprise AI adoption, trustworthy AI development, and global commercialization?
So if the ecosystem is like that, it can be a normalized evidence as the currency, right? So if device level verification is the global entrepreneurs wants to adopt, so that's a so a lot of startups are coming where in robotics or automotive side where they need verification of the AI models. So I would say I can and how global AI entrepreneur can accelerate adoption is by uh, finding us some good customers who are working on the same problem we are, or they are facing the problem which we are trying to solve, like the robotics or the automotive industries and medical devices which are running on AI. They want the verification, quick verification of their AI models. If AI, global AI entrepreneurs can help us find those right clients for us, have our EdgeGate um, the importance of the edge gate can be promoted through your platform. That will be very great,
Yeah.
the acceleration of this edge gate.
Yeah. Thank you. Thank you so much. So I think that gives our audience a lot to reflect on. So, what an insightful and engaging conversation. Thank you, Ashish, for joining us
you.
today. So, thank you for
Thank you.
sharing your expertise and practical insights with the global AIpreneurs community on the perspectives
Thank
of
you.
Edge AI and AI verification, trustworthy deployment, and so
Thank
many
you. Thank
other
you for
things.
having me.
Yeah. Thank you so
Yeah.
much. And to everyone joining us from around the world, thank you for being part of today's session. The future of AI will be shaped not only by the technological breakthroughs, but also by inclusive innovation, responsible governance, and partnerships that empower communities across every region of the world. If you are an AI founder, interpreter, investor, researcher, enterprise leader, or polymaker looking to become part of a trusted global AI ecosystem, we invite you to join us, the Global AI Pioneers. Thank you for joining us today. Until next time, keep innovative, keep collaborating, and together let's build a trusted global AI future. Thank you, Ashish, for joining us today.
Thank you. Thank you.